Hi everyone, welcome to the May meeting, our last one for the year, and we're glad to have you here. So we're gonna have fun with this last one because I decided to go out with a bang. So I'm just gonna go right in and introduce our speaker here, and our speaker here is Dr. Lisa Bucci. She's a hurricane specialist from the National Hurricane Center in Miami. Before that, she was a hurricane research scientist at NOAA's AOML, so that's the Atlantic Oceanographic and Meteorological Laboratory, also in the Miami area. She'd been there for 10 years before her current stint here as a hurricane specialist. Her work focused on new observing systems and integrating that into model data to see how it could improve hurricane forecasts. During that time, she was also um, an onboard scientist with the hurricane hunters. And this included being a director for the Hurricane Field Program, which oversaw the hurricane hunters in 2020. Just for some fun facts, she was part of the first all-female science crew that flew into Hurricane Lane in 2018, which was, for a fun fact, was a Category 5 storm. And this was also the first NOAA Hurricane Hunter flight that was launched out of Hawaii. Most of them are done out of the US or the Caribbean. Um, she's been through the high of the hurricane 67 times, which I find to be quite impressive. Uh, and that includes such notable storms as Sandy in 2012, Mathew in 2016, and Irma in 2017. She has her bachelor's from Earth Science in Earth Science Engineering from the University of Michigan, master's in meteorology from Florida State University, and a PhD in atmospheric sciences from the University of Miami. And I'm also glad to call her a friend. So her title for her talk is From Space, Aircraft, Land, and Sea to an NHC Forecast. So Lisa, the floor is yours.
Thank you so much, Steve. And thank you so much for having me here. I'm going to go ahead and share my screen. All right, are you able to see it?
We're good.
And, this is informal. If you guys have any questions or anything, just feel free to shout it out. But I thought I'd talk to you today about observation, something that I love and I have used and improved and figured out how to make them improve models my entire career. So I thought I'd talk to you about how we use observations to build forecasts, while also acknowledging that while observations are going to us forecasters, we're also seeing them indirectly as they're fed through the models, and then the model data is fed back to them. But I'm mostly going to talk about how the observations directly influence the forecast. So it's helpful to know what we have to define when we first walk onto a shift, and that is some of the things that you all know. So the center location and the intensity, the minimum central pressure, and then all the structural characteristics of the surface wind field. So those radii of tropical storm force 50 knot and hurricane force winds. And then we also sometimes just have to answer the question, is there a TC there, right? And we'll talk about how we do that a little bit later. So our first line of defense is those geostationary satellites. So a lot of times you'll see us just referring to, satellite imagery in our products. This is a snapshot from last year when we had the remnants or the beginnings of 5 different storms in the Atlantic basin. So it was a busy time last year. People are saying it's going to be busy this year. So we'll be relying on those geostationary satellites quite a bit. And then, as you know, we use the satellites to then zoom in on disturbances. We can use this to zoom in on the beginnings of a disturbance. Having that 1 minute data from the mesoscale really helps us be able to track low cloud motions and possibly be able to close off the circulation. So if we're saying a TC exists, it needs to be able to have organized deep convection and a closed surface circulation. But as you can see here with the first light imagery of Hurricane Laura, we also use it to for major hurricanes. So here you can see the sun rising on the eye, all that deep convection bubbling in the eye wall, and some of those gravity waves that are rippling away from the center. So the geostationary is great. We almost have it 100% of the time. Something has to go really wrong if we don't get that data. But we also rely a lot on polar orbiting satellites. So these are our, if we're lucky, it'll pass over the storm and we'll get information like from microwave imagery. And that's giving us not just information about what's happening at the cloud tops, but things that are happening beneath the surface. So this is an example of the 89 gigahertz microwave imagery, and there you can see a lot of structural characteristics of the storm that you wouldn't necessarily get to see looking at the tops. And we can also look at different channels to be able to get deeper into the storm, like the 37 gigahertz, and maybe be able to tell if there's a tilt to the storm or if the low level structure is, improving. But microwave imagery certainly is incredibly useful for us if we're lucky enough to get it. If we're also lucky enough to get it, we'll get ASCAP passes. So these are the surface winds that you get from satellite scatterometers. And what you can see here is that just based on the infrared imagery from the GOES, you might not be able to tell how asymmetric that wind field is or how far out some of those yellow wind barbs, those tropical storm force winds, extend outward from this tropical cyclone. So this geostationary satellite is very useful, but if you really want to know what those structural characteristics of the wind field are, it's really helpful to be able to get this ASCAT imagery. And with all this information from the satellites, we're able to then estimate the intensity from satellites. And that's oftentimes how we're getting estimating information, especially for storms that we're responsible for forecasting in the East Pacific. So, at NHC, we're responsible for forecasting everything out to 140 and everything in the North Atlantic. That's our area of responsibility. But the majority of the storms in the East Pacific we only use satellite information to be able to estimate all of those characteristics that I listed at the beginning. And so there's an example of Hurricane Hova from last season and how we used blended information from a lot of different sources. Some of them are people looking at satellite imagery and giving us estimates of the intensity. Some of them are automated. Some of them are even machine learning. And we use all that information to kind of piece together a story of where the system was and how strong it was over its lifetime. So if you had to think about the percentage of storms that you actually get aircraft into, I'm sure you have a couple different numbers floating around in your head, and I want you to kind of take a guess to yourself what it would be. And then we'll come back and I'll tell you how frequently we get aircraft into storms. But as Steve mentioned earlier, I did get to fly a lot for the 10 years before becoming a hurricane specialist. So here's a video of Hurricane Lane, the Category 5 storm off the coast of Hawaii. Okay, so hopefully the video will play right now. So it starts off in Iowa, and you can see that totally cleared clouds and then the video starts to lighten and you start to see the rain lessen, and that's because we're having a high. And all of a sudden you can see Iowa and just see clouds, strange and across the entire field of view. You see blue sky above, and then a moment out, we hammer down and actually the ocean. Actually, it's rare in that sky. This one was a bit pretty, we talk about beauty and then moving from that's a hurricane. It was just and at the moment, we're moving across that in the center of the eye, and we start heading back out the other side of the eye. So people always ask what it's like to fly into hurricanes, and every storm is different. And I just recently learned that this was one of the bumpiest flights that NOAA has ever flown researcher, a professor from Emory-Riddle, Josh Wadler, looked at the bumpiest flights for NOAA, the bumpiest being a flight into Hurricane Ian. And then the next 2, 3, 4 I was all on, and they were like Irma, Lane, and Hurricane Sam, which was an Atlantic storm in 2021. So what people don't know is that there are 2 different hurricane hunters. There's the NOAA planes that are based out of Lakeland, and then there are the 53rd. You'll often see those get confused, especially in the media. We'll be talking about a NOAA plane or a NOAA flight, and they'll be showing like a C-130. But the P3s are what I flew on most, so I'll show you what it's like inside of them. This is walking up to the plane. They can fly for up to 10 hours. Typically, missions would last about 8 to 9 hours. And the planes will hold up to 20 people with a lot of different jobs that I'll show in the next slide. You can see that every storm that comes through, it gets a sticker with its name on it on the side of the plane, and all the pieces that the plane has been deployed on also get a sticker. So inside, what you'll see are these stations with computers. We call them racks. Those are instruments that you drop off the plane in those big tubes that you just saw. And here I am walking onto the plane, going to where the scientists replace it. So who's on the plane? So you typically have 2 pilots. You can have up to 3, depending on the length of your flights. You'll have several scientists on the plane that come from both, the OAR branch of NOAA. They also come from the NESDIS branch of NOAA that fly on these planes. And they're responsible for conducting experiments, for testing out new observing systems. You'll have a meteorologist dedicated specifically to flight safety, and that's the flight director. And then you'll have a navigator too that's checking like your fuel, making sure you aren't dropping any instruments on top of people. You'll have engineers, 1 to 2, mechanics, data technicians, electronics technicians. So there's a lot of different people. And then we also fly everyone from, VIPs like congressmen or NOAA high-ups to students. Will fly our interns or other academics who are working on research using the aircraft data. As Steve talked about, flying out of Hawaii, we fly out of a lot of different places. So these are just an example of the places that NOAA has been deployed out of. And then, I also have on there a star for where Keesler is, and that's where the Air Force is based out of. And they fly out of a variety of different locations too. But you can see that we're trying to cover as much of the basin as you can, because we deploy these when they look like they're going to affect land. Again, the P3s are the ones that are flying in the storm, and they can fly anywhere between 1,000 to 10,000 feet. The lower you're flying is when the system is weaker. So in those invests, that's when you're flying closer to 1,000 feet. But as the storm gets stronger, you're going to see your altitude go up higher. And then the G4 typically flies around the storm, though if it's, in some cases, if it's a weaker system, they can actually fly over the storm. This is for things that are like a category 1 or weaker, and they're flying at around 40,000 feet. If you're thinking about how it flies through the storm, the basic objective is to map the structure of the hurricane and try and get a representative sample of the system. And you start off by flying a transect through the center, so shown in this green line. You'll turn downwind, and then you'll return back to the center. And you repeat that as depending on how close the system is to land or to your base, right? So the more time you have, or the closer it is, the more time you'll have in the storm, and the more times you'll fly through it. So a lot of times, if it's far away, you'll only fly what we call figure 4. That's kind of shown here. But as it gets closer, you might fly a butterfly or even a rotated figure 4. And you're constantly trying to solve this problem of like, where is the maximum 1 minute average 10-meter wind speed. There's a slightly different philosophy for how you fly cases that aren't systems yet. These are what we typically would call an invest, sometimes or a potential tropical cyclone. And those flight tracks kind of look like a free-for-all, or like my kid drew a scribble, but it's a flight track. And basically what they're trying to do is close off the circulation, and occasionally we'll have them fly out and look for some of the strongest winds so that we'll be able to tell, one, if it has that closed surface circulation, and two, if we should be calling it a tropical depression or a tropical storm based on those strongest surface winds. In terms of the instrumentation that's on board, you have quite a bit of standard instrumentation, so that's what I'll talk about today, though acknowledging that there are a lot of really cool instruments that are in research mode that are working their way to becoming operational. So you'll have instruments that are attached to the plane. These are like our flight level data that give us everything: winds, moisture, pressure. You'll have things that we drop off, instruments that we drop off the plane. Those are like dropsondes. We can also drop off instruments that measure the ocean beneath the systems. And again, those are measuring the same things that the flight level probes are measuring. So winds, pressure, temperature, moisture. There are 3 different radars on the aircraft. 2 of them are typically used for hazard avoidance, so we don't want to fly through some of those strongest convection. And then the radar at the back, the X-band radar or the tail Doppler radar, is what is used in the NOAA hurricane models, and it's also analyses are sent to the Hurricane Center to help us diagnose the vertical structure of the system. So you're getting slices every half kilometer, starting at a half kilometer off the surface up through like 18 kilometers, and you can kind of see how the circulation and the reflectivity changes with height. Finally, we use this instrument quite a bit, the step frequency microwave radiometer. It's a remote sensor that's looking at the brightness temperature of the ocean surface, and it's able to retrieve the wind speed, just the speed only, not the direction, and then the rain rate. And that's also used when we're estimating what the intensity is of a storm. So here's just an example of dropsondes that are released out. There's Mac there, and he's going to do a record. Hurricane Sam, he did 3 right there, just to kind of get a sense of, because a dropsonde, it's a parachute deploys and it gets blown around once it leaves the aircraft, so you don't necessarily know exactly where it's going to end up. You're hoping it stays in the eye wall, but sometimes it can get blown into the eye or out of the eye wall outward. So he released 3 to kind of get a sense of what that eye wall was like, and hopes that at least one of them stayed in the eye wall. And you actually have scientists on board who are quality controlling this information before it's sent off. So a lot of times, we'll be flying, everybody likes to see those eye wall imagery, but we fly a lot of early stage. Majority of flights are actually into, a lot of times it'll look like this, or it's not, there's a lot going on. We're in and out of cloud tops, but it's definitely not as dramatic as that lame video that I showed you earlier. And then, obviously you're flying 24 hours a day, so you might be flying at night. And this is a video from Hurricane Sam, and lower fuselage, and there were year of the props after Hurricane Sam, and we actually encountered quite a bit of grapple, and it dinged up all the propellers. So we do get a lot of, because we're transmitting all of this data live, we get a lot of people online who start to uh, advertise how they interpret the data. So this is my um, my plea to please be aware of where you're getting your information from. So in this example on Twitter, we were investigating potential tropical cyclone 6, and then this particular post says that they're going to name it Fred, and that the max winds were anywhere between 40 and 45 miles per hour. And of course, when the National Hurricane Center released it, it was still a potential tropical cyclone, not named yet, and the initial intensity was still 30 knots because this person was looking at flight level winds and not the step frequency microwave radiometer or the surface winds. So again, that's just my plea to please be aware of your information source. So I had asked how many times do you think we get aircraft into the system? So if you're getting like geostationary information 100% of the time, that's at least every 6 hours when you're releasing a forecast. About 50% of the time you're getting either some of the polar orbiting data, so you'll either get ASCAT or microwave satellite data, and about 25% of the time you'll get aircraft data. This changes as a system is making landfall. So if you have, in the Atlantic, at least for the last 30 years, if we had a landfalling system, we had aircraft in there almost over 90% of the time. The other 10% were typically systems that formed like right along the coast and were a surprise, or they were like an unnamed subtropical system that got its designation after the fact. So that's good news. But what was surprising when I started looking into this was about 60% of the landfalling systems in the East Pacific don't have aircraft in them. So we're trying to look for ways, maybe through like unmanned aircraft, to try and raise those numbers. So obviously we get observations from other places. So the NDBC, they have some great buoys that are available to us, and we can actually use that information for the wave heights too, which is used by our forecasters in TAF-B at the National Hurricane Center. We also have unmanned ocean vehicles. So this was a video that was circulating around from the sail drones showing the waves in Hurricane Sam, and they got up to like 40 feet or something. It was something really big. But this was just pretty dramatic video. It was also obviously sending us very useful information about the winds at the surface too. And finally, we use obviously land-based observations. So, the US is really lucky to have such great radar coverage and surface land network coverage. And that's always really great once you start getting into other countries. Either the data is obviously not fed through AWIP, so you have to kind of hunt online for other options, and they are not nearly as good as the radars that we have available to us. So those are always particularly useful, especially for those really impactful landfalling systems like Hurricane Ian. And then you can kind of see how that intensity estimate changes, or the story changes, when you start getting aircraft into the system, or more land-based information, and how our intensity estimate kind of rides the tops of those estimates. Except we do have some issues, especially with our step frequency microwave radiometer estimating some of the strongest wind speeds. So that was something that we ran into in Hurricane Dorian. And we're still trying to work out how we can get that observing system to perform better at those really extreme wind speeds. So, we have our products. They're released based on we kind of base it on our uncertainty. So the larger uncertainty, those are the longer, like the tropical weather outlooks, 7 days. And as an event is approaching, and becoming more and more of a threat, especially to land, then we start releasing products more and more frequently. So, for the outlooks we use them, obviously that data gets ingested into models, and we use the model data and the probabilities from those model data to try and assign probabilities of formation in Genesis. Since we have gone out to 7 days, this has been a little more complicated. The models obviously have a lot of uncertainty at 7 days, so we'll get information like this, which just ends up being a big head scratcher. But eventually we came up with something like that, and actually all of those systems ended up being ended up forming. And this was an example from last year, but in order to come up with this particular graphic, it took 4 forecasters, well, 3 forecasters and Mike Brennan, the director of the Hurricane Center, who happened to be on the floor at the time too. So, but we do use a lot of satellite data if we have it, and we'll put it into our tropical weather outlook. So here I have it highlighted here that recent data indicated the circulation did not have a closed surface circulation, and oftentimes we'll say whether or not we're going to be sending aircraft soon, or if we had it in the system recently. So there you can see how we're using our observations in our tropical weather outlook. When we're making a forecast, again, we have to provide information for the track, the intensity, and the radii out to 5 days. And once we make that forecast, all of these products start to fall out the graphics, including the cone with the watches and warnings on it, or the probabilities, the wind speed probabilities. But one of the things that you'll notice on especially the cone graphic is that, you know, we do plot out our surface wind estimation. So here we have our tropical storm force winds, and they are displayed on our cone graphic. So you can kind of see that we're using observations in our graphics to display the extent of the wind field at the surface. We're also using it in our text product suite, and here we're using it to help answer those questions that I posed at the beginning. So those center location intensity, and pressure, and the structure. We also use that information, or the TAFB forecasters use that information to give the 12-foot sea radii. So some of those buoy information. We also some research instrumentation on the NOAA aircraft that we're trying to operationalize actually can give us information about the significant wave height in storms too. So they're using all of that information to build radii for the 12-foot seas around a system. In our public advisory, observations can be used both in this beginning table summary, where we're talking about the location and the distance it is from major populations, and its motion and central pressure. We can also use it when we're in our discussion portion of our public advisory, and there we'll actually specifically highlight the observations that we may have used. So in this particular public advisory, they were using the Air Force Reserve Hurricane Hunter aircraft to determine that the intensity had increased. Finally, we use it a lot in our tropical cyclone discussion, and usually that first paragraph is almost completely dedicated to the observations that we're using and how it helped influence the decisions for what we were setting our intensity at. But there's a lot of other information that we include in there, like the changes to the forecast and uncertainty. Sometimes those observations may not agree with one another, and we'll talk about why we relied on one set of information, one set of observations more than the other. And then, we talk about our forecast reasoning. And that goes into our key messages, which also comes out in the key message graphic. And observations can be used to help as we're messaging some of the most impactful hazards for a system. And finally, as a system starts getting closer to land and we have watches and warnings up, then our products will start coming out more frequently. So we'll start releasing public advisories. Now on the in between our full forecasts, And in those, at that time, we're about to be, we typically, if we have storm surge watches and warnings up, that's when those will be released too. And this is where our short-term forecasts and the observations that we're getting in the storm at that time will be influencing, say, products like the peak storm surge graphic, which, you know, are influenced by the maximum wind speed and that the radius of maximum wind. And so they will start changing some of those values based on the storm structure and how we project that in the short-term forecast. And finally, you know, as a system is making landfall, we'll be doing tropical cyclone updates, and there we will also highlight specific observations that we're looking at, both the land stations and information from the aircraft. And finally, we use observations for verification. So we want to make sure, so this was a project that we did with our intern where we wanted to see if we were overwarning or overwarning or overwatching systems. And it turns out in the United States, if you focus on these cool colors, that about 87% of the time we were correctly either giving a hurricane or a tropical storm watch or warning for the United States. It's a little bit lower if you talk about outside the United States. And then we have this overwarned area of about, 12 or about 13%. And a lot of that is due to some of our, errors that you have with your track forecast. So you kind of always want to have a little bit of a buffer. You don't expect this to be 100%, but I was surprised at how low our aerial percentage was for the overwarned of only 13%. WPC also will use those observations for their verification forecast. So, they'll take the 3-day forecast that they had for, say, Hurricane Hillary last year, and then they'll compare it to the observations of the rainfall totals, and you can see that they had a really good forecast for Hurricane Hillary in impacting the California and the Southern California region. Finally, they'll use it for the storm surge. So, they'll compare what their forecast was. This was for Hurricane Idalia last year. And then they'll go back and pull up all the information that they can get from, say, tidal gauges and compare it to how they'll do this along with high water marks, looking at their storm surge forecast and how they can improve some of their modeling. And now a lot of that is highlighted in the tropical cyclone reports that are released each year. And finally, we'll use it for outreach. So here's a video that was taken of Hurricane Ian surge. Maybe some of you have seen this before, but it starts off and the surge is just beginning to come in. And what I want you to notice is that this house right here, and you can see the door started to open and the windows open. So they're actually here. Jumped out and swam to this structure behind them. And then obviously you can see what's happening to the house now, thankfully after they left it. But we use this to, emphasize how important it is to heed our watches and warnings, especially our storm surge watches and warnings, and the possibilities that could, of the conditions that could be encountered, and how, your structure may not be the safest place to stay if you're being asked to evacuate, especially if you're being asked to be evacuated. And now you can see, after the fact that house is just completely gone. So yeah, we use observations and they play a pretty crucial role in anchoring our forecasts and validating it. And then obviously we use it to improve our models and our forecasting. We try to use the observations intelligently and we blend it from multiple sources. And so we typically say that our intensity is good within about 10%. So if you have a 100-knot hurricane, it's good within about plus or minus 10% or 10 knots. We try to highlight our observations to scientifically justify our operational decisions. And I have a couple extra slides if you have any questions about any of the new products that are coming out in 2024. And with that, I'll close it off here. Thanks a lot.
Thank you, Lisa. That was awesome. I'll go ahead and open the floor up to questions, both here in the room and online as well.
I'd like to see the products in 2024.
You want to see the tracks for 2020? The slides. Okay, so we're going to be doing Spanish advisory text. So this is all going to be automated. This is being used. We're using AI to help translate our products. And we're doing it not only for the Atlantic, but also for the East Pacific. So we're trying to reach more people. You can see that we're going to be able to, previously, prior to 2024, we weren't able to issue watches or warnings on our intermediate advisories, so on the 3-hour time periods in between our full packages. But this year we will be able to. So the hope is that we can help start timing our watches and warnings to when we can reach the most number of people. So you won't be like issuing, say, a WIA at like 4 or 5 in the morning. You maybe can issue it after people have woken up. And we still, retain the option to issue special advisories, which can be released at any point if we're, if we encounter a situation that's rapidly changing. We're including web links in our public advisory. This is to help reduce some of the text that we have. These products can get like really long and people will stop reading them. So we're hoping that the web links to redirect them to some of the more information will reduce that text link. And then we can just keep the most significant and more impactful forecasts in our public advisory. We're also extending out our forecast of that, the structural information. So before this, we would only do forecasts for the wind radii out to 3 days, but now at 4 and 5, we're going to be adding those tropical storm force and 50-knot radii. And then this is all happening internally, but we'll be using the hazard recommender tool to coordinate our inland watches and warnings with the local WFO. Obviously, this isn't going to, if you're at the WFO, this is something that we're going to be trying out this year. But what it should, how it should be reflected publicly is the use of inland watches and warnings on this experimental code. It should display that. This should be available sometime around mid-August. And the hope is that it will better convey the wind hazard risk inland. The graphic won't be available immediately, but we're excited to roll it out, and any feedback or comments are definitely welcome. And so there's an example of like what it could look like for Hurricane Harvey in Texas. And how the coastal watches and warnings looked and how they could look with the inland. So that's everything that I have for the upcoming.
Yeah, I really like that inland warning. That's very helpful.
Other questions? Yeah. So I guess I'll go ahead and ask 1 or 2 here. So what do you think has been the biggest improvement in observations over the last 10 plus years that you've been a part of this mission?
I mean, the use of that tail Doppler radar data has evolved a lot over the 10 years that I was both in research and now in operations. Before it was just something that was done offline after the fact, and they have taken it, they've automated it, they have gotten data assimilation to ingest it, and they're actually looking at ways for it to be ingested into the GFS too. So that's really cool. And now they're looking at ways to just completely operationalize it. So it has evolved a lot over the past 10 years, and it's significantly, like, the coverage that you get from that radar is significant compared to all the other observing systems that you have on the aircraft. So that's been a big game changer.
I can see that, yeah, with a lot of new data assimilation, just having that coverage.
Yeah.
So then, what do you think would be like the next area of advancement you'd see in the next few years to help with all this data collection, these observations?
You're seeing a lot more AI tools. So like trying to blend all of these data sets together. So you're going to probably see a lot more of that. You're seeing a lot more unmanned aircraft or unmanned vehicles in the system. It could be aircraft. So they are actually launching unmanned aircraft from the P3s that fly like low down in the boundary layer where, obviously manned aircraft can't fly, but they're talking about launching long duration unmanned aircraft to just kind of follow the storms and fly over them. So that is something that you might see in the upcoming years. And then we have both gliders underneath the storms and those sail drones that I was talking about. So you're just seeing a lot more use of unmanned vehicles with different observing systems trying to get observations around and in hurricanes.
Yeah, I can definitely see that. And I know from our end, there have been rumblings about stratospheric balloons with dual pole radars attached to them. So it'd be cool to
Yeah, we have had
whenever that comes.
Yeah, it's like long duration balloons that were like going across the Atlantic and getting those like Eastern Atlantic that we really can't get observations. It's all
Yeah, it's an exciting time.
Yeah.
Are there any other questions or no? Anyone online? I guess I'll just leave it with one final one. Given everything that you've flown through, do you have a favorite storm?
Ooh, I mean, I loved Lane just for like that. I got to fly with all my girlfriends and like that was just a lot of fun and it was such a pretty storm and you got to go to Hawaii. So that was like awesome. All the things were awesome. And that particular storm, I was also working on a new instrument, a Doppler wind lidar. And that was for my dissertation. So it was fun to just like, I didn't think that this observing system would work in a major hurricane. It's kind of works better in like early stage systems, but it worked in Hurricane Lane. So that was also really exciting. So I really liked that whole experience. But every storm's different. Every storm has like a positive, like a cool story associated with it. So it's hard to pick. But yeah. Lane might be my favorite.
I can see why that one had like all the wins there. Cat 5 in Hawaii with the
new instruments and like all my girlfriends.
Awesome. Well, Lisa, thank you very much. It was
Thanks
great.
for inviting me. It was a lot of fun.
Yeah, it was great to hear all of this, and we appreciate your work. And I will email you later. We do have an Amazon gift card for you for speaking to our chapter, so I'll get that out to you soon. And yeah, thank you so much.
Thank you. Thanks, everyone.
Thank you.
All right. Now, if you want to, you can drop off now, Lisa, because now we get to the fun part of the chapter business. And hopefully I'll see you at AMS. So.
Yes. All right. Bye, everyone.
All right. So obviously this is the end of the year. So we usually go into the fun part of electing officers. We've had some thoughts too about like how what else can we do here to like kind of re-image and revamp the chapter. Obviously we've had a few struggles coming out of COVID. Obviously the first few years were all virtual, so we got to spend a lot of quality time at home. Plus the fact that some places couldn't really access like this one, like this facility here. We've tried a few different things over the years between Amanda, my predecessor, and myself with, different times, different ways of outreach locations. Some has worked, some hasn't, and we're also aware that sometimes it's harder as a professional chapter with career people versus that of student chapters when you just hold it at the university and everyone shows up after class. So there's things that we still have to work through with this, and then we've tried different ways to grow our attendance and outreach with not a whole lot of success. I think the hardest part has been trying to engage the community, especially the professionals that we have around here. Like DFW area is a pretty big area. We have a number of weather service entities between the forecast office, the RFC, the CWSU, the aircraft, the aerial forecast group, and so the region. Plus, we have all the media and the private partners around here. Well, obviously, it's tough. We're all, a lot of us are working people who are working through the day, and then we have to try and take care of families and whatnot afterwards. So it's, I understand it's been a challenge, and part of the reason why I'm relinquishing my role as president is because I have so much on my work plate now. I've spent the last few days out in the field doing data collection, and that gets to be tough. So we can talk about.
Yes, sir. Tim Marshall. Yeah. Has there been any? You guys go out and give spotter talks all over, and I'm wondering, is there any promo that's being done during the spotter talks about the AMS NWA chapter?
Not that I'm aware of, and that's conducted by the Weather Service. So that is a good idea to have that brought forward.
Maybe that'll help. Something like that.
Yeah.
Also, isn't there? I don't know if it's called a Chaser
Con.
that was held earlier in the year up at the racetrack. That would have been another promo opportunity, I think, too.
Yeah.
Because they're talking a lot about, I guess they're talking about more than just chasing storms now.
Oh, okay. I didn't know.
Yeah. Martin Lynch just has this TESA meeting every couple of years. I don't know if that's going to continue or not. I wasn't able to get to the last one. I hope it does continue. Maybe Scott Ray knows more about that than I do, but that's another thing that we could maybe have a promotion there or a combination meeting.
This is scheduled for 2 years. Next one, 2026.
Okay.
Yeah, Tim, I haven't heard about the future, but I think it's still continuing. He hasn't talked to me specifically about that, but yeah, it's every other year.
I know we've tried, we do have social media pages, but I guess getting that outreach out to other groups is key. I think probably the hardest part is actually getting the engagement from people like the Weather Service here. It's tough. I'd say it's tough right now because everyone's in operations. It's been a pretty busy spring. So I appreciate the thoughts here on this. I'm trying to reimage and how we do things. And I know there was a consideration I came up with potentially just setting up for a break to kind of take a step back and kind of reset.
Open the discussion with the national AMS NWA.
Yeah.
And see how they're addressing this with any other chapters. Is this just us, or is it?
Yeah, talk with Janice Bunting, who runs NWA, which, by the way, NWA is here in Irving this fall, so not far down the road, which makes it a really easy trip for us. Makes it easy for me with work.
We should hold a meeting there.
They do get
Oh,
600 people or so in attendance. And granted, it's from across the country. It's at the Irving Convention Center the third week of September, somewhere in that 13th through 16th or 16th to 17th time period. Yeah, I just know this has been a challenge, and I mean, I'll freely admit I haven't been too much of a help with it. I try and
You've been a great help.
Yes.
You've tried very hard.
yeah,
It's
I could have.
nothing to do with you.
But maybe there's ways we can just kind of think about how we can re-engage with the Weather Service or maybe some of the other groups around here to help with promotion and getting more people on board to help out.
Is the National Weather Service no longer involved?
There's no one from the Weather Service in the officers, and I mean we are here in their facilities every now and then. I guess it's hard to determine what
I
that.
think Amanda was the last person that was.
Yeah, Amanda was the last one, and sometimes a few will jump on the calls and listen, or would sit here in the room. I don't know. I don't know how to bridge that gap. Tom wants us to to have more involvement. I guess just get more people in there.
And that may be the thing is we start a dialogue with Tom and the Weather Service as well as these other groups that we talked about earlier. See if there's interest in reforming. This is the word for it.
Yeah, remolding or
Whatever you wanna call it. It'll take some leadership, and there's just not enough time in people's days to weeks to for many people to do that. And we also we've always talked, we wish we had younger members, but that's not easy for fruition either. So.
we had that few months stint with we tried a bit with with UT Arlington, and that didn't really pan out. We had a few students stick around the first one, but they never came back. And that was a challenge.
And we'll talk about this for months, I suppose, but I guess we need to approach them differently. Maybe as I sit here thinking about it now, is maybe ask them, what are you working on in school? Can you do a presentation? Bring them into bring their studies and whatever into the chapter, and not just be a meeting.
Yeah.
I think the first thing they do is you and Stan need to sit down because obviously your job. Stan, you've been awesome. I've been involved in this for 20 some odd years, and you've been here since day one. So thank you very much for all your time and efforts. Time to take a break. So,
yeah.
Thanks, Dan.
Unfortunately, the body says it's time to quit.
Understood.
But I do want to say that unless we get the MIC at Fort Worth, the HIC here at Fort Worth, the regional director, the commander of the weather detachment out at Carswell, on board to support the chapter, it's going to be tough. I've watched over the last 2-3 years the support from those 4 areas that go in almost zero.
Yep.
And and there's a mess of meteorologists around this area here, and the ones that just work for those 4 people.
Yeah. Yeah, between the groups and the southern region, and then we know there's a number of, heck, even there's like storm chasers that base themselves out of here.
But when I resurrected the chapter back in the 80s, I had full support from all 4 groups. And we average 30, 40 people at our meetings.
There used to be standing room only when we still with.
Yes.
Yes.
Mhm.
It seemed to drop to the COVID period seemed to just switch that off. I mean, it's just,
Yep.
Yeah.
things changed and never came back.
Oh man, we did have one meeting. It was standing room only. So Tim, you're gonna have to speak at every meeting from now on.
Can you do some pre-recordings and that way you'll have a lineup for it?
I think
No.
we don't have anybody, I think, that's available to step into your position. But do we not have somebody that's volunteered to fill the treasurer's role?
Yeah, which was I was just digging that up real quick.
There was one person that asked us about it, but he's not here.
You did not.
Yeah, Ken Schneider.
He's right there.
Hi, Ken.
Oh, that's-
I'm gonna- Nate,
I was looking for the wrong person.
I was yeah. I apologies.
It's okay. Nobody knows who I am. I'm the new guy,
You're the
so.
new guy, and that's why we didn't-
So okay, well, I guess we can go through a few of the formalities here real quick. So we'll start with the role of treasurer. So I guess the nomination is for Ken Schneider here. So
I will second it. Okay.
all right, it's been second. All those in favor?
all right.
Aye. All right.
Aye.
Opposed?
There you go.
Hearing nothing. Welcome aboard.
Appreciate it. Thanks, you guys.
All right, secretary. Dave, I believe you're.
If there's nobody else that wants it, I'm fine. Continue going.
All right. We need a second for Dave.
A second, David.
Second. I third it.
All those in favor?
Aye.
Opposed? All right, hearing nothing. Dave, welcome back. Vice President, Greg.
I will serve until a new president wants to make different changes.
A second for
I second it.
second, third.
Yep.
All those in favor of Greg? Aye.
Aye.
Opposed? Nothing. Greg, welcome back, sir. Guess the question is
Anybody open? for president?
anyone open for president right now? Yeah. Hearing none,
We will search.
I will. Yes, I can remain as a consulting role for now.
I move that Steve be allowed to serve in the consulting role as president until such a time as we can identify a successor.
I second.
Favor? Aye.
Aye. Aye.
All right. I hereby am now a consulting emeritus. Yeah. Consultant. Oh, that sounds dangerous now.
No, you don't get paid for it either.
Unpaid is the
Yeah.
worst.
So I guess until then,
Greg's the boss.
yeah, Greg is the boss, and you are hereby acting president. Greg, the floor is yours now.
Thank you, Steve.
Is there any other new business to be brought before the board at this time?
I guess the one question is how do we go forward? Should we do we set ourselves up to kick off again in September, or do we just wait and see? And
My suggestion would be let's get together. We can do it by Zoom or however we can, the board now, and discuss this for the next month to 2 months. Come up with a decision first part of August.
And in between now and then, talk with
Janice,
Janice
Tom, and
and Tom.
the other folks involved,
Anybody else that's interested in-
and then come up with a decision. We can announce in August if we're going to, what form we're going to come back in September, or if we're going to take a hiatus for a year.
whatever it needs to be, half a year, just
Whatever
something
we
to.
decide. Yes.
Okay.
Is that agreeable to all? Excellent.
I'll just, I guess for my last act here before fully handle the reins, I just want to say thank you to Scott, Shannon, y'all there at North Center Texas Council of Governments. It was great for you to help host us over the last few years. It was great to meet you all and work with you all, and hopefully I'll get to see you all there again soon, and kind of drop by for a meeting if they're ever there, or maybe I can just loiter around the building. Who knows?
There you go.
Or see you at science fairs. I still plan on doing science fairs regardless. I thought it was fun. I enjoyed it. Yeah, and then want to thank the folks here at the National Weather Service, Tom Bradshaw, Jason Johnson, who lead the FO and the RFC, to allow us to use their conference room here as well. Okay, I said all I say. And Stanley, thank you, sir.
Thank you, Stanley.
Yes, sir.
Very much.
So,
Well, you can sit in your chair and enjoy it through Zoom and not have to worry about getting up and out.
yeah, kick back, relax.
Yeah, we get to get it together.
Okay.
It's just a box.
Okay,
Can we sit over there? Or?
No,
Oh, okay.
I'll hand it over. Okay, it's all yours now.
Is there any old business before the board? Hearing nothing, do I have a motion to adjourn?
I second. I motion and somebody else.
Motion adjourned has been made. Thank you, everyone. We appreciate all you've done. You know how to get a hold of us through social media or webpage, things like that. If you have ideas, please spread the word. And we hope to see everybody back next September.
Okay.
All right.
So thank y'all.
Thank you.
Thank you.
Thanks, everybody. Thanks, Steve. Stanley.
Thanks.
Restroom here.